part 3 of my build video for a GPS assisted ionizing radiation survey meter. Parts 1 and 2 are already complete, and of course once I'm finished the whole lot I'll go through the title of these videos or the descriptions and update the links, so you'll see them below once this is done. So a quick little update if you haven't already seen the other videos. This is a little device designed to measure ionizing radiation and log it along with its GPS coordinates and a few other bits of information. Now I've already injured myself in this. It's taken months to get parts in for everything because I'm both poor and also I live in a rural area. Stuff's hard to get. So in any case, if what you're watching is a little out of sequence and it doesn't make sense, that's because I've cut this into a multi-part video when it was originally intended to be a big long video. But when I hit the 30 gigabytes mark of footage, I thought it's probably time I made this multi-part. I'm not going to squeeze it inside half an hour. So, and I do try and keep my longer videos to a maximum of about half an hour. This would have been like a 2-hour documentary by the time I'm done with it. So, yeah. Anyway, enjoy the next bit. The bit you're looking at now is where we pick up halfway through the Raspberry Pi side of things. As you may have seen, there is a Geiger counter in the bottom. There's a Raspberry Pi inside this bit, which I built in yet a different video entirely. And there's the real-time clock and all the other stuff under here. So, yeah. All right, where we're picking up now is we've finished the component at the bottom here, or we've finished as much as we can of the Geiger counter. I lost my train of thought there for a minute. And we're picking up in the Raspberry Pi construction. So let's jump right to that now. All right, so here's where I dig up an old project of mine. This is my Raspberry Pi and a reversing monitor. And everything is nicely tucked into this case. So this is going to be fun. We need to see if we can fit a real-time clock into this before the very start. And I probably also need to set up auto login to the GUI on this graphical user interface. So we have a real-time clock module here that takes CR2032 batteries. I do have some little midget ones, but I kind of like these more. I can replace the battery. The midget ones usually show up with flat batteries. This one actually has a crystal timer on here, so it might actually be a little more accurate. So that's got to go in here. There's also a GPS module to come in, and there's the interface to the Geiger counter board, which I can't do till I've got all the parts for that ready. I have a few other bits and pieces. At the moment, this thing is using an inefficient LM7805 linear regulator, which I can probably show you up close here. It's got a linear regulator that gets hot enough to melt the hot glue I'm using to insulate it. So I'm going to use something a little more efficient. I'm going to pull the guts out of this, which I have spare. I'll test it first because the fact that this has been used in the past tells me it may not work, but we'll find out. So the very first two things we need to do. This has got a Raspberry Pi 0W in it, which means it has Wi-Fi. And that means I can connect it to the Wi-Fi. I can use SSH. It makes downloading all the data I intend to record with this much better. And it saves me having to have like SD modules and program everything up on the Arduino and stuff, much like the idea of having a GUI. And I've even gone to the trouble of having some USB connections here, so I can plug in like a cordless mouse or a little wireless keypad or something like that to suit my needs, or even a USB memory stick if I want to make backups. So yeah, let's crack the bottom off this and see how we're going to fit everything in. It's worth noting too that I do intend to make up, I have grand plans of making like an armband based unit and have this sitting up here, but it might turn into something a little bigger than that. We'll find out. Let's get the back off this. Okay, so there's not a huge amount of room to work with in here. I've got my USB hub here. This is a bit of a hot glue special, as I like to call it. I use lots of hot glue. So this is the USB hub up the top here. This is the display driver. This is the Raspberry Pi Zero, and I had to trim down some of these connections to make it fit. This is a bridge rectifier to help correct the polarity in case somebody happens to plug in a different adapter. And of course the choice to use the regulator externally was one based on heat. It's pretty clear to me I'm going to have to extend this case somewhat to fit the real-time clock in and also the GPS. So I might have to look at mounting this to a bigger container. And I do have a couple of donated boxes, so I'm trying to decide, and maybe you guys might to make a comment on what you think as to whether I use a prefabricated box or whether I 3D print something crazy looking that fits on my arm. At the moment, I'm thinking I might pack it all in a box and use an external connection for a probe. So yeah, this is a bit of a decision I'm going to take a few minutes to think about before I start filming again. Right, so in the meantime, I'm going to dismantle this USB regulator. So I need to get down to the bare bones board on this. I'll take all the extra bits off. These usually just have a rubber cap which is glued in the bottom, but because this one is a new one, or a newish one, hasn't been used much, I haven't got around to removing the cap and there's still rubber in there. So let's see if I can re-injure that same finger that I jabbed a hole in with the chip legs earlier. Alright, there it is in its entirety in the back there. Now, usually I'd like to pull on the leads, but that does damage it. But let's just give it a gentle tug. Yep, a little bit of hot glue that holds it on has broken away. Now this is a much more efficient way of regulating down the voltage, and we've got an inductor here, a couple of capacitors, and a little chip here. I assume that's something like a 555. I have never actually looked at that very closely, but that makes a mini switch mode regulator, which is a lot better than a linear regulator. It doesn't waste nearly as much power as heat. So when I'm going to be running on battery, this will be much better. Okay, so now that I dismantled that perfectly good piece of equipment, I had a better idea. Tinkerman Mick had dropped off some nice little units here, the DIY battery bays for 18650 cells. And I noticed that this one is all in parallel. I also happen to have a couple of unused 18650 cells. In fact, I think I've probably got 4 of them somewhere else in my workshop. I'll have a look. And I also have this. Now, it occurs to me that these are a regulated 5-volt output and they're a battery, and they're a very nice high energy density. I'd almost had plans of using a backpack mounted 7 amp hour gel cell. Well, this will probably do just fine. And I do have some switch mode based 3.3 volt regulators that I'll be using to run the Geiger counter boards. Because as you see here, they're designed to take two AAA batteries. So 3 volts. So I can probably run everything off one of these supplies, and they're much more readily chargeable and a lot more lightweight. So we might go down that path. Look around, and I did dismantle a good battery pack some time ago from some damaged equipment to try and make a replacement laptop battery, which didn't go very well, largely because the chip under this blob here was dead. So I might dismantle this and use 4 of these cells, and we'll see how that goes. I'm getting a little distracted here, but I want to try and work out the power circuit before I figure out the dimensions of everything else. Alright, so I've extracted 4 of these cells, and they're all quite healthy. 2 of them are at 3.9 volts and the others are about 3.7. So I'm not sure what they're going to do when I put them in parallel. But yeah, hopefully nothing too major, unless I just give them all a good charge up individually. Now the method I'm using to pull these apart might be a little bit brutal, but it's something I did pick up from Tinkerman Mick's videos. I've mentioned him a lot lately, but there's been a fair bit of collaboration and sharing of skills between us recently, which I can't be too unhappy about, I must say. But and I've got some shakes still at the moment, so I might need to tend to them again. So alright, it's been a bit of a tumultuous day. Alright, let's get these installed and see what we can do. So I had some grand plans of doing this with fancy laser cut stuff. And excuse my apprentice in the background there, she's having some fun. I had grand plans of doing this with laser cut things or 3D printed bits and pieces. But some sticks of hot glue did the job just as well. So it seems to be working. I'll give this a charge up and see what happens. But yeah, alright, I'm kind of happy with that. Right, so I'm halfway through gutting this and I realise a problem. The monitor is 12 volts, everything else is 5 volts, and my rated Geiger counter is going to be 3 volts. So I can't use that lithium pack, it only puts out 5 volts. So I have this 12 volt battery pack, and I think I might be able to stack that with rechargeables and maybe get just enough to run the monitor. Or I could use disposables. It really depends what I'm going to do. But that's if I want to make it battery operated. I could always go with a lighter socket or something like that and run it from a vehicle. But yeah, this hopefully will give me enough time to do the job. And what I'll do is I'll fit an isolation switch for the monitor so that I can turn that off when I'm not using it and save a little bit of power. But I probably do need to do a current test. But you know what, I think I'm going to whack all this together and I'm going to worry about the battery later. The battery's less of a problem, but it does mean I need to disassemble that switch mode regulator again. Anyway, we'll pack it all in. Crucially, with the change of real estate in here, I can probably fit the real-time clock in here now. So that will be nice. And the next step will be finding the connections I need to fit it. Alright, so let's keep moving. Right, let's just disconnect the fan here. Well, where am I up to? Well, I've connected some DuPont connectors here after carefully checking all the pinouts. That's a little bit close up, but that should provide enough for me to connect the real-time clock module and also an extra ground and a GPIO 26 for doing my radiation sensing. The next thing I've done, which we'll pull our camera up to have a look at, let's come up here. I found an external box and I've decided to use the base of this as the top, counterintuitively, and I've mounted the base plate for this reversing monitor / computer on the top and drilled a couple of holes in key places to run all my leads through. And so I'm going to mount the batteries and everything in the base of this box and have most of it happen in here. This will provide me the ability to add auxiliary switches and bigger battery packs and lots of future proofing. We'll see that as I get there. But this is where I'm heading with this. And it will allow me the ability to use these leads here and switch off the monitor as I do it. Let's see if I can get some really jerky footage here. So yes, we can see the blue wires here are for the display unit and oh, that's the video going in, that's video input. I saw the brown wires and got scared for a minute that I was putting 12 volts back into the Pi. I'm not. The green wires over here are the 5 volts in. Alright, let's keep assembling this and hopefully we can keep this video under an hour. But I don't know, there's a whole lot to do. Alright, so I have some basics working at the moment. I have a clip down here that allows me to disable and re-enable the screen to save some power. The screen can of course fold up and down as it always did. We can see underneath here I've got the 5 volt supply working and also the real-time clock is wired in and a couple of spare connectors for GPIO 26 I think, which is interesting because I'm going to use that for radiation counting. But we can see over the back here, oops, sorry about the lumpy camera turn there. Yeah, I'm working on the RTC code at the moment and it seems to have gone in all right, but I think I've got the wrong GPIOs. Well, it's quite late at night too. It's nearly midnight, as is usual for me. So yes, I've managed to work out what the current century is. They could have just said put 4 digits for year. That would have made more sense. Anyway, apparently 2119 is outside its date range too, incidentally. But yeah, from here I've got to work on getting the real-time clock working. And I'm probably going to go through this whole process again when the GPS arrives. So we'll skip over all this bit. You don't need to see this nitty-gritty stuff. If you do add some comments, I'll do a bit of video and demonstrate what I actually did to get it working. But we need to keep this moving. There's so much to do. Okay, so it's the next morning and I've done a little bit of work. And I'm up to load testing. We're pulling about 230, 240 milliamps with the screen running. And upon testing, I find it pulls about 100 milliamps with the screen off. We can see under here, I've also now set it up to run on some batteries. The real-time clock is working, and I've moved the voltage regulator position. These are all held down with blue tack at the moment, and I'm running off a test supply here at the moment. That all runs back to this connection here, which I'm doing through the multimeter at the moment. But yeah, it runs off 12 volts or thereabouts. But yeah, it's working quite well at the moment. So the next job will be to write a routine or a script or a Python, whatever we want to do, to try and work out the radiation count and all of the GPS. And hopefully the GPS should show up sometime soon. Okay, so we're a little bit further down the track. Let's just do a bit of progress. At the moment, this is going to be close to the end product, at least the outside shape. We have our monitor that can pop up on the top. We have our on-off switch and our power LED, and an apprentice throwing a protest in the background about something I haven't checked on. We have 3 USB ports we can make use of, but for the moment we probably won't be using them. To come will be a monitor disable switch and a power button, and maybe a little membrane pad if I can find it, with some arrows and stuff. Inside we have lots of hot glue, and I'm not going to apologize about that. This is a one-off design. We have a real-time clock which is now working, our 5-volt regulator. We have my little temporary connection here for testing, and on the base plate I have the Geiger counter board with a 3mm screw mountings. The screws go all the way through the bottom here, and that places the Geiger tube towards the outside edge of the unit. I'm yet to run some tests to find out how much radiation this will actually block. It will probably block alpha particles. This is polyethylene, and usually polyethylene, having a high proponent of hydrogen in there, does tend to block alpha particles, and generally electrons as well, so it might even block beta particles as well. So I'm going to have to find that out. If that's the case, I might end up grinding a nice big window in the side here, or we'll simply not mount the tube on the board. We'll put a socket and we'll mount it on a probe somewhere else. But that's a project for when we actually get the Geiger counter working. We do actually have the chips programmed, as you just saw, and we're pretty well on way. We're just waiting on some more components for this to happen. The next job I've got is to program a routine to write a KML file and all the rest. So I do need to come up with something that will count pulses. So yeah, that shouldn't be too hard with a Python script, or even a shell script for that matter. So yep, we'll come up with that at some point. I'm not sure if I'm going to have this write to a CSV or actually compile a KML. I'm going to have to source some help from another associate of mine as well. Not Tinkerman Mick, a different guy this time. He's pretty much a master in his field, so we'll consult him about how we're going to write KMLs. Anyway, yeah, we're going to sit around and wait for some components. So the next installment you see in this will probably be a bit further down the track. But through the miracle of editing, you'll see it very quickly. Well, the donations continue. Actually, this isn't really a donation. This is a delivery. And I think I know what these are. I've already opened this. These are 3.3 volt regulators. Yet another part for my Geiger counter kit, or rather Geiger survey meter. Anyway, we'll get to them later. Alright, what else do we have? Right, some new components have arrived. And again, it's almost midnight. Yawning. These tiny little midgetized things, we'll bring it right up to the lens. These are 3.3 volt regulators, complete with a little inductor and everything, and tiny surface mount components. So these guys are going to bring down the 12 volts from the batteries down to the 3 volts needed to run the Geiger counter. So now I've got to arrange all these clips in such a way that I can test it with a multimeter. So let's do that. Okay, so let's just explain what we've done here. We've got our common negative from our 12 volt supply, And then we have our positive, which is actually black here because it's the only clip I had left, from the volts out. We'll just double check that. That says VO, I'm guessing, for volts out, and VI for volts in, and a G for ground in the middle. So this is 12 volts in, that should be 3 volts out. Let's see if we can blow it up. We're getting 12 volts, so clearly I need to check what's going on here. Alright, so I figured I've probably got this backwards, but I figured there's a surefire way to test. Turn the power on, so clearly that one is shagged. Let's try another one. Alright, so I thought I'd just check up the stats before I burnt out another one. Turns out the maximum input voltage for these is about 6 volts, or 6.5. These are not going to work for what I need, so I think I'll probably go one of two ways. I'll put an LM7803 in here, which is a 3.3 volt linear regulator, good for about 1.5 amps. And they can take about 28 volts in, I think, or somewhere about there. Certainly at least 12 volts. Or I'll just put a couple of double A's on the Geiger counter. I think that's what I'll do. I think I'll be much happier with that. And I'll put an opto isolator on it between the two sides so that I don't get 400 volts in my Raspberry Pi. I think I'll do that. Alright, I've done a little bit of work in positioning everything here. I've also made just a little baby breakout board so that I can avoid all the big blobs of hot glue that I've just sneezed everywhere here. And this bit of blue tack is just keeping these wires out of the way. I'm run out of toggle switches, but that will be the monitor disable toggle switch. Let's go over everything else that's in here. We have 5-volt power supply, real-time clock, on-off switch, LED, which I couldn't fit the nut on, so I just stuck in with hot glue. A little breakout board. There's these two spare GPIOs out here, which are 21 and 26 off memory. And we have GPIO 14 and 15 in readiness for the GPS module. And the rest is most of the power system, which I have jerry-rigged onto the back of the regulator here. Now, I have been carefully documenting where everything goes here, including the Cat5 cabling for the power on the monitor. It's just little, like, I've ripped the cores out of Cat5 cable because they're easy to route. I've got all my DuPont connectors labeled here. I should really change that from green to something else. But we can see the color of the jumpers to the sections on the breakout board that I've come up with. I've lost my mouse. Let's move over here a bit. And so we can see I have all the pinouts on the breakout board, and I have two connections bridged for ground here, and these are connected by little link wires underneath. And so we can move over here and we can see that my two spares are the yellow and the green. The purple has connected 5-volt to the GPS here. Red and black are not connected yet. And all my real-time clock stuff is pretty well connected directly to the clock, so it doesn't have to go through the breakout board. So we're pretty well as far as I can go until new stuff arrives. I might neaten this up and put some little boxes around stuff to make it a little bit more readable. But yes, I am keeping track of everything after I scribbled randomly on notes and stuff. Yeah, and I'm getting some of the programming ready to understand the GPS. And I might work on having this write a CSV file fairly soon. Now, I decided to take some time to check the documentation and go over this carefully. Now, this little 8-pin chip here, I put an E555 in here as I saw it called for a 555 chip, and I went, oh yeah, 555 timer, flip-flop circuit with 2 transistors. Makes sense when you're trying to oscillate up to 400 volts. What I neglected to look at was this 2 AAA thing. That means we've got 3 volts going in here and not the minimum of 5 for a normal 555. And he's calling for a TLC 555 CP, which upon looking up the data sheets for that and comparing to the 555, I realized that's a low voltage one and it's a low current, so hence the TLC. The LC stands for low current, which is designed to operate around about 3 volts. So I'm going to have to dig them out because I didn't have 8-pin chip sockets at the time, and put a chip socket in them. But that's easy enough. That gives me something to do. So yeah, at least having some time to wait for components is getting me to double check my work. But yeah, they wouldn't have worked at all without that, as they wouldn't have been able to generate the flip-flop circuit to oscillate through the inductor, through the diode to step up to 400 volts for the board, which you wouldn't want to put your fingers like that, or we'd be having a pretty comical video right about now. All right, so I've got to dig some chips out. It's all right, I've got spare boards. Oakley dokley. Okay, so we're up to the next stage of the Geiger counter. Some more bits have arrived. What has not arrived is sleep. So, I can't do much more at the moment because the prototype is in my senior financial manager's vehicle, aka my wife. So, but I do have some bits. Some timing crystals have arrived, including some 8 megahertz ones. The GPS module has arrived. I was actually just working on that yesterday. I'm happy that arrived. I checked on all the tracking numbers last night and it didn't look like it had gone anywhere. So that I am happy about. I've got some toggle switches from the local J-Car shop. He's a great guy, that guy. If you want to deal with him, talk to this guy, okay? This is not a paid sponsorship, but he's done the right thing by me. And I'm pretty sure he'll do the right thing by you guys. So I have some toggle switches. I've got a DC socket for when I run this on 12 volts directly, which will be nice. And I've got some more DuPont connectors because I cut my others up. And these are also a little bit longer than what I already had. So I've got to sit around and wait for it to come home, which will be in about an hour's time. About as long as this video is going to be by the time I'm done. Anyway, let's cut to that.